We're going to reset our filtering. So we bring everything back up. Change the process name back to our piece of malware. That way we can have a full view. So from here, we can deduce that we found 2 possible command and control servers that it was trying to reach out to via Fiddler. If you want to go and dig more into that, you can. So this would be something that we want to document within our notes. If I can find the actual. That just URL. We have a solid start of a lot of stuff that we can go and use as IOCs for this particular piece of malware. We also have our hashes to it. Let's minimize that. All right, one more tool that I want to point out is a tool called Autoruns. And Autoruns, it shows what malware likes to use as persistence mechanisms. So we'll go into the system internals suite and we will run the tool called Autoruns, which another, if you guys want to take, guys are taking notes, Autoruns is a good one in conducting dynamic analysis. So what this is going to do, this is going to show everything that is set to automatically run on our system. And again, just to reiterate, a lot of malware's goal is to persist on our network. And we'll let this populate for a second. Okay. And this looks very familiar as part of our registry change that we saw earlier. So I don't know if you guys remember, we were looking in the strings portion of the E section. We saw this registry path referenced in the strings. And this could be a possibly dropped piece of extra malware that was used for persistence mechanisms. So we'll want to document this as well. And then we'll go and explore what this FECAB, whatever that is, just some strange thing. We'll go and explore what that actually is, okay? We'll throw this in our list of notes. The cool thing about Autoruns, if we want to go and, we should also, it is an exe. Let's document that file path. So we have 2 indicators within our file system. We have 2 network requests, and we have some stuff going on within the registry that we should take a look at. All right, so we can right click this and we can jump to the entry in regedit to see what's going on with this, okay? Let's just boot back up. Waiting game, here it is. So let's jump to this. This takes us straight to our registry. And as expected, there is an executable inside of the run registry, which means that this is possibly a use for persistence mechanism. And we could probably conclude that this piece of malware dropped this extra executable onto our file system or in our registry for further persistence. So if you try to go and delete, either of these two pieces of malware, it'll just come right back after we delete. Okay. So let's see if we can delete it. See what happens if we delete it. And we refresh. And it comes right back. So yeah, this is a persistence mechanism. So what we want to do is we want to go find this program within this path and do our analysis all over again. So we'll start again with our static properties analysis just to see what's going on. And I'm going to try to find it in our within this directory. What do you know? There it is. So let's take this out. Let's minimize some of this noise. And we'll just drop it in PE Studio again. So obviously, it's something that we need to look at more closely. And this is a very basic piece of malware. It's nothing too strenuous as far as analysis goes. But what it looks like, and if we compare our hash values, so when we took the hash value of our initial piece of malware that John sent us, we had 73 as the first first couple digits of the MD5 hash. And we also see here that this malware has the same hash value. So we can conclude and put in our notes that this was a dropper piece of malware that copied itself into the registry for persistence mechanism for the purpose, if the analyst decides to just delete it from the local machine, it'll always have a way back on. And so that's just creating more persistence. It's going to always be there, and it makes it harder to remediate this effort without seeing these indicators. Okay? And so that's pretty much what static and dynamic properties analysis is. We're taking the time to go and view the basic properties, whether it be the strings, imports, the different hashes. We want to verify that it is in fact an executable, and we want to run it with our monitoring tools, which we have observed. And just to reiterate, we ran Procmon, Process Hacker, and a tool called Fiddler to conduct our dynamic analysis. We use PE Studio for the static. However, there are other tools that I hope you guys go and research and find out more on your own, in which we'll have more of the resources for you guys who want to do that. Okay. So now that we have our conclusion as to what this malware is, we have our list of IOCs. You see the different mechanisms that it's trying to do. We can send this to our level 3 analysts, and they have a wealth of information that they can go and conduct further analysis, whether that be reversing this actual piece of malware to get more in-depth information and creating those signatures for the better protection of our networks. All right, so that concludes the demo portion of our talk. I'm going to pivot back over to the slides. Okay. All right, now I guess we can open up the floor for questions. I think I see a couple in here. So, all right, yeah, good answer. A lot of malware, as you know, the guys that actually write the malware, they're a little bit more forward thinking than what we would normally think. So they will write some type of sandbox or VM functions to see if malware is actually running in a virtual environment. And to do so, just a workaround, you can either run it there on a machine that is not virtual, or you can do that by means of, you can find out what's actually going on by means of reverse engineering and performing code analysis and getting a bit more in-depth information. You won't be able to deduce a lot of, what's the term I'm looking for? You won't be able to deduce a lot of the anti-VM detonations from static analysis or just basic dynamic analysis. Like, you will have to actually go in, review the code, review the functions within the code, and you'll be able to conclude your answer there. So yeah, it's either, to answer your question simply, you can run your lab in a non-virtual environment, which is run it bare bones, or you can perform a higher level of code analysis. Okay. Next question, in terms of efficiency, how does having your own setup compare to using tools? So again, I think I'm not too familiar with what any.run is, but I'm assuming that it's some type of simulated sandbox environment. And as you alluded to earlier, it's malware can, it's very aware if it's running inside a virtual environment. And that could be one reason why having your own setup and analyze it on your own is, it's more efficient, because of course, if you run it in a simulated sandbox environment, you won't actually get the information that you